Hey guys, so this is video 1 of 2 for the periodic table notes. So we're going to talk about oxidation numbers, valence electrons, Lewis dot diagrams, things like that. So the first thing I'm going to focus on is valence electrons and how they help us determine, bonding and things like that. So hopefully you remember from class the definition of valence electrons. A valence electron is, or are, as I should say, valence electrons, they are the electrons in the outermost shell. Outermost shell. And more importantly, they are the electrons that are responsible for bonding. So anytime there's an interaction between two or more atoms, it's because of those valence electrons, whether they're being lost or gained or shared. So responsible for bonding. Okay, so what does this look like? Well, we can use Bohr diagrams to help us sort of visualize those valence electrons. Say, for example, we're looking at the element beryllium. I know that beryllium right here, beryllium has 4 protons total, and so if he's neutral, he also has 4 electrons. So I'm going to come over here, back to our notes, and I'm going to say beryllium. And I'm going to draw this Bohr diagram. Remember, the Bohr diagram is like the orbitals, and then they have electrons on them. And, however many we have, that's how many we have. We basically draw dots to represent electrons. So if beryllium has 4, I'm going to start filling out my shells. I have 1, 2. Now, if you remember from your past, the very first shell is full after 2 electrons. So we can only fit 2 electrons. Once it's full, we have to move on to the next one. So I have 2 on my first shell. Then I'm going to put 1, 2 here. 2 plus 2 is 4. So I didn't need this shell here. So now if I'm looking at valence electrons, I know that there's 4 total electrons, but in terms of the valence ones, the ones in the outermost shell, well, there's 2 on there. So 2 valence electrons. And when we look at the periodic table, beryllium here, he just so happens to be in group 2A. We only care about the A's. These are the B metals, the group B. Those are the transition metals, and they do some funky things, and we're not going to worry ourselves with that right now, so we're just going to look at the A's. So beryllium is in group 2A, and he just so happens to have 2 valence electrons. So let's just take a look at another one. Again, just as a example, let's take a look at, let's do sulfur. So sulfur, here we have sulfur. Sulfur has 16 electrons. So now we got to fill out these shells. My first shell, again, remember that we can only fit 2 maximum, so 2. And then our next shell, I'm going to add, let's see, how many do we need total? 16 total. So I need for sure another 8. So 1, 2, 3, 4, 5, 6, 7, 8. And so far I have 10 now, right? Every shell after the second one is full after 8. So before I can add more, I need to get another shell going here. I have 10 and I need how many more? 6 more. So I'm going to do 1, 2, 3, 4, 5, and 6. So if I add all those up, 2 plus 8 plus 6, that equals 16. So I have 16 total electrons. And if I count the valence electrons, I have 1, 2, 3, 4, 5, 6. So 6 valence electrons. And again, I'm going to go over here and look at the periodic table. If I count across my groups, I have 3, 4, 5, 6, 7, 8. It just so happens that sulfur is in that sixth column and it has 6 valence electrons. Well, that actually isn't a coincidence. The periodic table is arranged in such a way to help us with information like this. So when we look at our column numbers, that 1, 2, 3, 4, 5, 6, 7, 8, that number is going to represent the number of valence electrons. So we don't have to draw this diagram every single time. We can just use our periodic table and say, oh, well, carbon, he's in group 4, so he has 4 valence electrons. And that's always going to be the case. So valence electrons, outermost shell, responsible for bonding, those are going to be the same as the group number. And we said that these are important for bonding, and I'm going to show you guys why. So basically, all the elements on the periodic table want to be happy. What does it mean to be happy? To be happy means to have a full outer shell. And over here, if these guys have 8 valence electrons, then that means they all have a full outer shell. Those are our noble gases. The noble gases are the happiest elements because they have a full outer shell. And every single element on the periodic table wants to be just like them, including beryllium and sulfur. So let's say beryllium wants to be happy, and he has some options in order, to get to that happy place that he wants to be at. He can either, again, he has 2 valence electrons, right? He wants to be happy. So he can either fill up this shell by adding 6. So 1, 2, 3, 4, 5, 6. So he can add or gain 6 electrons. Or he can take kind of the easier way and get rid of 2. He can lose 2 electrons. And electrons are lazy. They want to be happy and they want to be happy now. So when beryllium, is on that quest for happiness, he's going to go with the easier option. He's going to try to lose 2 electrons so that he can be happy, so that he can have a full outer shell. Once he loses these 2 electrons here, his shell, his outer shell, is going to be this one right here. And again, remember the first shell is full after only 2 electrons, so he'll be happy. Taking a look at sulfur, he can also lose or gain. If he were to gain electrons, how many would he need? 2, because he has 6, right? So 2 more, so he could gain 2 electrons, or he could lose 1, 2, 3, 4, 5, 6. He could lose 6 electrons. And now which one do you think he's going to do? Hopefully you're saying gain 2, because again, that's easier. So he's going to gain these 2 electrons, and that would make his outer shell happy. Because if we look, now his outer shell is going to have 8. So if we look at beryllium and we look at sulfur, we know these guys he's not just going to kick out 2 electrons and we're going to have magical electrons floating around. That's not how it works. We don't just have free electrons. In order to be happy, they need to give or get those electrons from somewhere, from someone, particularly another atom. So beryllium, he's floating around. He's like, hey, I really need to lose 2 electrons. And sulfur, he's floating around saying, man, I really need to get 2 electrons. When these 2 meet up, they're like, oh my gosh, you are everything I need. And it works. And so beryllium gives his electrons to sulfur, and sulfur gets those electrons, and then they have opposite charges, and then they're happy, and it's just a match made in heaven, and it's happiness. And we're going to talk a little bit more about those charges in the next video. So there's valence electrons and how it deals with bonding in a nutshell.